So here, let me repeat it. Find terminal point of vector starting by a and equal to v, and I want the endpoint. And am equal vector v. So xm minus x of a, ym minus y of a. Y minus 3 here, minus 1 equal vector v. So x plus 2 equal to 2. Y minus 3 equal minus 1. Z minus 1 equal to 1. Here, find a starting point of a vector ending with b, and nb equal u plus v. If you do vector u plus v, you're going to get minus 3, 1, and 3 plus 1 is 4. You equate the first and the second and the third, you're going to get the point n. Here now, write vector a, b, u, and v and w as a linear combination. You can start by a, b, u, or v, or w. It depends. And I started by a, b. Linear combination, there is a relation between these vectors. It means a, b equal a parameter a times u plus parameter b times v plus parameter c times w. This is called linear combination. This is a vector a, b equal a vector u plus b vector v plus c vector w. So I have three equations. 7 equal minus 5a plus 2b plus c, minus 1 equal 2a minus b plus 2c, minus 3 equal 3a plus b plus 3c. Three equations to three unknown, you're going to get a, b, and c. Now we're going to start by this one. Let E to A3B5, find A and B so that AE is parallel to vector U. Now two vectors are parallel, U and V, if A over A prime equal B over B prime equal C over C prime. So the components of AE, so E minus A, so 2A plus 2, 3B minus 3, 5 minus 1, 4, parallel to vector U. It means 2A plus 2 over 2 equal 3B minus 3 over minus 1 equal 4 over 1. If you do it, you're going to get A and B. Now this dot product or scalar product. The scalar product is the multiplication of two vectors. By definition, it's norm u times norm v times cosine of angle between u and v. In that case, the product of two vectors is a number, because norm times cosine, all are numbers, so it will be a number. However, sum of two vectors is a vector. And cosine of the angle between two vectors, it's a scalar product uv over norm u times norm v. Now, if u and v, the scalar product is positive when cosine is positive, it means between 0 and 90. And it's negative when cosine is negative between 90 and 180. And if the angle is 90, you know the cosine is 0. In that case, the scalar product is 0. So when the scalar product is 0, when the two vectors are orthogonal. Application, find the angle between uv given norm u, norm v, and u times v. So what's cosine uv? It will be scalar uv over norm u times norm v, which is minus 1 over 3, and cosine inverse, this is 109.5 degree. Now, suppose you want to do u times itself, so it's norm u times norm u, and we know the angle between u and itself is 0, cosine 0 is 1. So scalar product of u times u is nothing else than norm of u squared. Given u and v, we need to find u times v. We wrote it here in scalar component, u1i plus u2j, u3k, and vector v1, v2, v3, I, j, k. If you multiply, you have all of these. You know, in three-dimensional, the norm of I, j, k is 1, and they are all perpendicular to each other. So here, I times j is 0, I times k is 0, j times I is 0, j times k is 0, k times I 0, k times j 0. So what remains? Here scalar I times I is equal I squared, which is 1 from the property here. So it will going to get u1 v1 plus u2 v2 plus u3 v3. So what is the scalar product of u dot v? So u dot v, you can write it in two ways. It's either u1 v1 plus u2 v2, where u1 u2 u3 are the components of vector. So u times v scalar product is u1 v1 plus u2 v2 plus u3 v3. So if you have two vector uv, u1 v1 plus u2 v2 plus u3 v3, or norm u times norm v into cosine uv. Now I want to write all this one using the components of u and v. So you know that u dot v here in the cosine is u1 v1 plus u2 v2 plus u3 v3, norm u radical u1 squared plus u2 squared plus u3 squared times square root v1 squared v2 squared plus v3 squared. And if the angle is 90, so u1 v1 plus u2 v2 plus u3 v3 is 0. Now in this example, they gave us vector u not as norm, as scalar. So 1 minus 2 here, 632. So find u dot v. U dot v will be 1 times 6 minus 2 times 3 minus 2 times 2. So it will be minus 4, and norm of u will be 3, and norm of v, if you do this one, 7. So the angle will be, it will be minus 4 over 3 times 7, which is 21, which is 100.98 degree. Given u and v, find a so that u and v are orthogonal. It means the scalar product must be 0. So 6 minus 6a minus 4 equal to 0. In that case, a will be 1 over 3. Now I gave you, we have vector uv and point a and b. Evaluate vector sum times vector sum. Vector sum is a vector and vector sum is a vector. Vector times a vector is a number. So I must have here a number. So I do 2u minus 3v, 2u minus 3v, so 2 minus 18. Okay, it's minus 16, minus 2 minus 9 is minus 13, minus 6 is minus 12. And this is vector AB, XB minus XA, etc. So AB minus vector U, you're going to get, this is AB minus vector U. You have the components. So you need to multiply these components by these components. So we're going to get minus 16 times minus 6, plus minus 13 times 7, plus minus 12 times 5, which is minus 55. Now I have two-dimensional, like three-dimensional. I have A00, B35, C52. Find the angle between of the triangle. So this is a triangle. I want to find angle A first of all. So what is angle A? Angle A, it means I want cosine ABAC. So cosine ABAC is AB, scalar product AB times AC over norm AB, norm AC. Now AB is what? B minus A, AC, C minus A you have here. So scalar product, it will be 15 plus 10 over norm 9 plus 25 into norm 25 plus 4. It was three-dimensional. We add plus ZZ prime, up and down. So the angle A 37.2. If I want to find angle C, so it will be CA CB. So scalar CA CB over norm CA CB. You do it the same one as we did above, and you're going to get 64.7. So scalar product of a vector times scalar product of two vectors is a vector. So this was the scalar product. Now we're going to go to video number 3, which is called the cross product.